Alright, so I have all the gears set up on the banjo. There's some play in the shafts. This shaft's a little bit scored where there's a little ball detent here that'll allow it to lock in to be in the out position or the in position. So I may have to remake this shaft, and they got a little bit of play on there, so once we get this up and running, we'll see how much they rattle, but you know, it moves okay. Worst case scenario, I'll just have to remake those shafts. Not a huge thing. If I go down that route, what I might do is just see if I could take a piece of bronze and cut these down, slip the bronze over it, give a nice bearing surface for that. So now down below here, I have the motor mounted. I know some of you were concerned that I wasn't going to be able to get that motor in there. Some of you may have had problems. You had to lift up the bell housing, put it in from the bottom, but I was able to get it in through this area here, and using some blocks, shim it up and get it bolted up. Took a little bit, pain in the ass doing it by yourself. If you got to do that, I recommend somebody help you. So what I'm going to do right now is put on the V-belts for this, and I'll show you how to do that. Okay, so on this motor, depending on how yours is set up, this pulley you can see, dual belt, has no set screw. What it does have is a tapered key. So this is, I believe the technical term for this is a gib key. So this is tapered, and once you tap this in, it locks the pulley in place, and this little tab here sticks proud like so to allow you to get a screwdriver in there and pry that off. Sorry if the lighting's kind of crappy down here, but obviously we're down in the land of shadows. So it's marked. You can see the punch mark right there. That's the back, because obviously this key has a taper to it. So what we're going to do right now, slide that on, start the key, and take a straight edge, put it up against this pulley here and that pulley there, and this is only a preliminary line up. Might have to move it a little bit, but this will kind of get me in the area I want to be in. Alright, so that's pretty close. Now the belts we're going to be using are just two 4L470s. I matched it to what was there. 4L470s or an 845, same belt. So what we're probably going to have to do is adjust that motor up. I'm going to hook one belt, put it in the pulley groove. Actually, what you should do, if you can, is we'll do the back first. Hook it on the back, start it in the small pulley, and then just use the weight of the larger pulley to bring that right around. Okay, that's in place. Okay, I'm going to put the other pulley in place. The other belt on the pulley. Okay, give it some attention. Now what I can do is take this straight edge again, run it up against the side of that pulley, and sight down as best I can with the edge of this belt and see if this pulley, motor pulley, has to go in or out. Okay, so now as far as belting goes, I was going to order basically the same belt that Brad has on his lathe, and a lot of other people have it on there too, and it's made by Albino. I know it's a weird name, but I think it's like flatbelt.com or something like that. Well, I'd ordered a belt, and then the next week I had actually got an email saying that from them saying that they're actually closing the business. So they're no longer in business, at least as of this recording. So I asked around, and my friend Rich turned me on to a place local right here in Woburn, Mass, called Olmsted Flint. Now they've been around forever, for over 100 years. They've been around. They've been around since 1910, I think, or something like that. They do all kinds of flat belts for everything, conveyors, all kinds of stuff. So I told them what I had and the length of what I wanted. I didn't get a glue belt. I did get a clipper lace belt. If you talk to them, maybe they can figure out a glue belt solution for you. But I got a clipper lace in case I ever got to move this lathe. I don't have to cut the belt. I can just unlink it. And I kind of have an idea of how to get rid of the clicky as the clipper belt goes on. So called them up, and they cut it for me. I had it pretty much next day. And super good service. I talked to the guy there and said that, I basically told him that there are a ton of these types of lathes out there, and the guy that was kind of famous for doing a lot of flat belts for him, he went out of business. And do you guys do shipping? And he said, yeah, they do shipping. So if you need a belt, give them a call. They'll ship to you. And so what it is, it says, you can see it says transmission belting on there, and it has the length that I needed, if I can get it out. So it's nice and supple. It looks stiff, but it's not. You can see how thick it is. It's maybe about 3/16 of an inch. It's rubberized coating on either side here. It's very grippy. Feels almost like the serpentine belt that I have on the 9-inch lathe, and you can see it's clipper laced. We can frame it in the camera there. That would help. And they supply the pin, which I'm assuming is underneath that piece of masking tape. So let me go ahead and get this installed and see how she looks. Okay, so now that we got all the belts on there, I can get the drive all set up and get all the wiring run and actually start this thing up and see what the hell happens. So obviously we have a 3-phase motor in here. I obviously am in my house. I don't have 3-phase power in, so we need a drive solution. So for a normal home shop guy, there's 3 solutions to get around that. The cheapest solution is a static phase converter. So basically what that is a big metal box with a relay and a bunch of capacitors in it. So it gives that 3-phase motor the kick over that it needs to get started, and then the 3-phase motor can run on its own off of your household 208 input power, 208 single phase. There's a few drawbacks with that. The good thing is that it's cheap and they're readily available. Drawback is you're only going to get 3/4 or roughly 3/4 of the actual nameplate horsepower rating. So if you have 1 horse motor, it's probably only going to output maybe 3/4 of a horse. They're kind of temperamental. I had a friend that had one, and he had a problem with the relays and everything else in there, and the thing was brand new. But it's a cheap solution. It'll get you by. The most expensive solution and the best solution for a larger shop will be a rotary phase converter. So a rotary phase converter is more of a whole shop solution as opposed to a individual piece of equipment solution. So basically what that is a bunch of electronics that start a 3-phase generator, an idler motor that produces your three-phase power, and there's a bunch of electronics in there that are usually used for filtering and stuff, and there are different grades of rotary phase converter and stuff for CNC machines or a regular machine, depending on how sensitive the electronics are. They're great for multiple pieces of equipment. You can size one for all the motors that you have, get one rotary phase converter, and run your whole shop off of it. The only problem with that is you'll have to have a feeder wire large enough to pull all that amperage in, which for me really isn't that much of an option here, since I only have a 100 amp service here, which that's on the books for an upgrade, but for now that's what I have. Plus they're a little more expensive. They do make noise depending on the brand. They can be relatively quiet, but they still do make noise. And also you have to run that motor all the time to run each piece of equipment. Alright, so if I'm running just this lathe, I still have to have that massive rotary phase converter running no matter what to run a piece of equipment. But again, the good thing is you can run all your pieces of equipment off of one unit. My option, what I went with, is a VFD. Now, variable frequency drive is a really good per single piece of equipment option. You can see I have one on the mill right there. That one there is a Tico FM100. That is a single phase input, and it's a 3 horsepower rated drive driving a 1 horsepower motor. So I can actually go up to 3 horsepower with that motor. Now the benefits of a VFD are it's an individual piece of equipment solution. Usually for us in the home shop environment, usually a feeder wire is probably not going to exceed at the most, say like 10 gauge, so it's manageable to run the wire to each equipment, not a huge thing. It turns that 3-phase motor into a variable speed drive, and it also allows you to have the nameplate rated horsepower out of it. The only problems with it is electronic. Sometimes you get the electronic gremlins in there, and also depending on your hearing, it varies the frequency to the motor. All right, so it runs at a really high frequency. You can hear it. You can hear that high-pitched whine to it. It's a little annoying. I can hear it and I can pick it out really easy. Some people can't. It's a little bit of an annoying thing. It does show up on the videos. It does show up in the camera. I can hear it on my film. But it all depends. But like I said, that's what we're going to go with. So what I have here is a Lens 1 horsepower rated VFD. The actual model number ESV751N02YXBXX1G43. Wow, that's pretty long. So you can see that there, all the stats. Now when you get one of these, you want to make sure, even if it says 1 horsepower, you want to make sure that your amperage rating on your 3-phase side, which on this one is 4.2 amps. Okay, my input rating is rated at 5 amps, and my output is rated at 4.2 amps. You want to make sure that that amperage rating is higher or the same as whatever motor you're using. If it says mine is 3.2, I believe, or 3.6, so we're well within there. So if for any reason this says 3 amp output, I would have to go one size bigger to get the amperage to pop that. Now, this is a single phase input VFD. So this is designed to take 208 single phase input and create 3-phase output. Single phase input drives are usually only going to go up to around 3 horsepower, which is what that is. And you can see the size difference in that compared to this. Anything larger than that, what you have to do is get a 3-phase input VFD. You can still use single phase input with it, but you have to derate the drive. So you take your nameplate amperage on your motor, multiply that by 1.73, figure out what that amperage is, and get a drive that's rated for over that amperage. Usually, rule of thumb, it'll be the next size up. Okay, so what I'm going to do is I'm going to mount this on the wall, and this is actually going to be out of reach. We're going to build our own remote panel, which will live in this box, and this box will be attached to the leg. As far as wiring goes, I'm going to run the wiring, but I'm not going to hook anything up. I'll go through hooking it up with you guys. So what we have so far is I'm running it off of the same circuit that this VFD is on. I'm never going to be using these two at the same time, so that's not an issue. This, I think the amperage rating on this was 11 or 12 amps, and the amperage rating on this is 5 amps. So what I have is a 15 amp breaker, 15 amp 2-pole breaker, and I ran 12 gauge wire through, and it's to a switch right there. Now, obviously 12 gauge wire is good for up to 20 amps. I like running the larger wire. I like running 12 gauge whenever I'm putting a circuit in, even if I only need 15 amps. That way, down the line, if I ever need to, I can slap a 20 amp breaker in there and not rerun anything. The price difference between 14 gauge wire and 12 gauge wire for running circuits in your own house is negligible. You only get into crazy price differences when you're an electrician and you're doing build outs. So if you can, just run the 12 gauge wire. Trust me, you'll thank yourself later. So basically what I'm having is two switches that are parallel. So that switch right there is controlling that VFD. I'm gonna have another switch right here that'll be controlling this VFD. Again, won't be running both machines at the same time, so that's not an issue. Coming out of the VFD and feeding the motor, I have 12 gauge 4-wire SO cord. Now, there's SO cord and SJ cord. They look almost the same. Usually SJ has the it was a the plastic covering instead of the rubber covering. This is SJOOW, yeah, is the technical term. So basically this is oil and water resistant. This is good for outdoor use, good for machinery. And the difference between SJ cord and SO cord is the voltage rating of the insulation. SJ is 300 volts, SO is 600 volts. Again, price difference is negligible. You can get this at Home Depot. I think the price difference between both of them is like 50 cents a foot. Get yourself some SO cord if you're going to do that. So the SO cord here is going to be coming from the motor going up to the VFD, and then this here, which is actually sprinkler wire, 7-wire sprinkler wire, is going to be coming from the VFD and going to our remote box. So let me mount everything and get the wire run, and then we'll go through the hookup. Okay, so we got the SO cord coming out of the terminal on the motor, going down underneath the motor, going through that slot in the casting. I have it zip tied to the column here. We're going up over that drain line there, and we're going to our VFD, which is mounted on that beam. Now ignore this fitting. I need another one. I need another 90 like that. Hardware store just only happen to have one. From there we get another piece of SO cord going to a 4-inch box, and then from the 4-inch box is my main power in. So right here will be a 2-pole switch, and then all my connections will be here, and then off of this terminal strip here will be my remote panel, which we'll get to that. Okay, so this is where the 2-pole switch is going to live. Sorry for the funky angle, but you know, I got to work on this. So good old electrical code. You can't just zip screw a ground to this anymore. You need the threaded hole with a actual threaded fastener. So I'm going to start that in its home here. Okay. Then we're going to take our ground wire off of our feed. I'm going to go clockwise around that, like so, and then on top of that, we're going to put our ground that's going to our VFD. Slip that right under there, and Tighten that screw down nice and tight. Let me get a flathead. So now this ground wire here will be hooked up to our switch. You need to ground the box and ground the device. So I'm going to take these wires here, cut them even. Strip back a little over half an inch, 5/8 of an inch or so. Bend a hook on each of these. Two-pole switch, labeled line and load. And make sure when you put it in, it says on and off, not no and faux. We're going to be putting a switch plate on these, so we don't need these ears or this screw. So all you do is just nip those ears right off. And then you just pull the screws right out of them. Because that switch plate is going to have its own screws that are going in the other holes. Okay, so put our line on our line, which happens to be our black. Doesn't matter which side. Just make sure that the hook is hooked clockwise around the screw terminal. So when you tighten the screw terminal, it tightens the wire around the screw and doesn't push it off. And then the ground, same thing, goes on the grounding screw. Then, again, doesn't really matter which side. Put our fork connectors on either side. Alright, so over the years I've gotten in the habit of wrapping electrical tape around the device just because a lot of my stuff is outdoors and it ain't gonna hurt anything. And all I happen to have is green down here. The black electrical tape is in my van and it's raining right now and I don't want to go get it. So this white wire here is extra. I'm not going to clip it in case for any reason we ever need it again. All I'm going to do, just to make sure it doesn't touch anything, is we'll just throw a wind nut on the end and that'll insulate that wire. And like I said, it's there if I ever need it. And then my cover plate. Okay, make sure we're on and off, not no and flow again. Okay, there's main power in. Alright, you're not going to be able to see much in here, but the left 3 screws on the bottom here are T1, T2, and T3. Those are the ones that go to the motor. And then on the right side, L1 and L2 are the ones that we're going to be using for our power in. If we had 3-phase in, we could do L3. The reason why you would put 3-phase into a phase converter is to allow you to turn that 3-phase motor into variable speed. But we're using this to change our 208 single phase into 3-phase, so we're just going to be using L1 and L2. So I'm going to do that off camera because you're not going to be able to see much in there. Okay, I actually had to cut the those fork stake-ons off. These screws have a plate. They're designed to have the wire underneath them, and the screw terminals were too small to fit the forks in there. So just cut those off, put the braided wire underneath, tighten it down, we're all set. This white wire is just taped and stuck in there all the way in the back. It's not going to touch anything. And right through this hole here is where our control wire is. I know it looks a little crowded in here, but I actually got a ton of room in there. So let's go down to the motor and make our connections down there. Okay, all my lines are connected. They're connected with screws and bolts. That's what they were before. So now we need to insulate those. So what I have here is electrical rubber insulation tape. So it's really thick, it's rubber, and it sticks to itself. This is basically the stuff they use on services and bolt-on wire connectors. So we're going to wrap all those up. I already did this one here. I'm going to wrap all those 3 up. The ground's just put to the screw that holds that terminal on, and then we'll put the terminal cover on and we'll see if everything works. Okay, let's power this sucker up. Okay, we got lights. I think that's a good thing. Let's hit the run button. She's moving. Alright, so I'm going to adjust the acceleration time. Do the book here. And let me read through this and see that acceleration time on a little bit faster spin up than that. Of course, I had a 50-50 shot of getting the phases right, and I was wrong, so I got to switch to those wires. Right now it's in reverse to run forwards. Ignore this connector. I need to get another 90. Lowe's only had 1 in the entire store. I don't know either. Yeah, it's Lowe's. What are you going to do? So press the big green button here. And it moves. Sounds nice. The little noise that you hear, kind of like a noise, is actually just this bearing going around. It's nothing big. And that's the needle thrust bearing that I put in there. As far as vibration goes, this thing is not level. I can still rock it back and forth a little bit. And we're pretty steady. And this is on its fastest speed. No real vibration there, everything looks nice. Now we have project box, a couple of switches, potentiometer. We're going to rig up our own remote panel and mount that sucker right here.